Hi students, this is Mrs. Schmidt, and this podcast and slideshow will allow you to make up lab number 1 from the unit. The purpose of this inquiry activity is to learn about the trends of the periodic table through recreating Mendeleev's card sorting. Please pause the podcast and read your background and procedure before proceeding. You also will need to have picked up and checked out a set of the cards from me or from Mr. Fain. You will see, if you hover over the top bar, that you can get a PDF download of the procedure for this lab, which includes a background, and the data table, which you will need both of these printed out in order to continue. The element cards are to be checked out from me or from Mr. Fain. You will need to have the data sheet, your lab notebook, and your exit ticket is going to be your data sheet and the post-lab questions.
Read the experiment overview and then proceed to the next slide. The diagram on the left side of this slide shows you the order in which the facts are placed on the element cards. You should take them out of the packet if you have not already and spread them out on the table. Each card has up to 9 facts on it about the element. The legend shows where this information is located. For example, the top number on the left side of the card is the ionization energy, and beneath that is the atomic mass, and so on. Do you recognize any of these words? If so, which ones? What do you remember about them? In class, the 3 that most of the students did not know much about or even recognize are shown on the screen. Read the first definition and look at the picture. In your science journal, in your own words, write a definition of the word. So that means that you will read ionization energy, the energy required to remove an electron from an atom. And look at the picture. Now, in your journal, think about that definition and write it in your own words. Then repeat that for the next 2 words shown on the slide, electronegativity and atomic radius. When you're done, move on to the next slide.
Students in class worked in their learning teams and had 30 minutes to complete the activity. Since you are likely working alone, this podcast will include a few helps to get you started. Pause the podcast at this time to review the task slide before proceeding. Refer to your procedure again if you need to clarify what you're going to do. Your goal in this activity is to recreate Mendeleev's card sorting. You'll recall from reading the procedure earlier that he had an idea that the periodic table, that the elements could be arranged and grouped according to their properties, according to how similar their properties and dissimilar. So read step number 2 in your procedure. If you look at the screen, I've chosen out 3 cards. I chose them by looking at the atomic mass and the formula for a halide, which is represented by the symbol X and H. Open up your deck of cards that you got from Mr. Fain or me and spread these cards out on your bench and find the same 3 cards shown in the diagram, placing them on your workspace as shown on the slide. For example, if you look at the top leftmost number for ionization energy, you'll see I've chosen out the cards that have ionization energy 520, 496, and 419. Now you're going to look at these cards. Let's look down the cards at ionization energy, the upper left-hand number. How does ionization energy change as you look down these cards? Ionization energy is decreasing from 520 to 496 to 419 kilojoules per mole. Now I want you to look at the letter combinations on the cards. These letter combinations represent formulas of a compound that the element can make with other atoms. The letter X represents one atom of the element. The other symbols represent chlorine, Cl, oxygen, O, and hydrogen, H. Do you see a pattern in any of these formulas? What pattern do you see? Did you write the answers to these questions in your journal? If you didn't, pause the podcast now and take care of that. When you're finished, flip to the next slide.
I've added a card to our arrangement. It's the second one on the top. Now look across these two cards. What happens to ionization energy? Does it get bigger or smaller? Now look at atomic mass. Does it get bigger or smaller? And, as an aside, excuse the typo, that 0 was supposed to be a closing parentheses. Now find that fourth card that has ionization energy of 801 and atomic mass of 10.8 in your set of cards and place it into your arrangement in your workspace. Then move on to the next slide. Now I am giving you another card. Where would you place this card into the pattern of the cards at the left? And why would you put it there? Give yourself time. Look at the pattern that already exists in the 4 cards at the left, and then look at the facts on the card with the pen pointed towards it. Place it into the puzzle. Think about why you placed it there, and then move on to the next slide. The new card best fits in the top row and between the 2 cards that were already in the table. Do you know why? Take a moment to think about it if your answer didn't match. It really is okay if you put your card elsewhere so long as you had a reason for it, a reason for placing it there. Think about what you might have done and what this solution shows. Why does this card fit best in the location shown in the diagram? Look at the pattern of ionization energy, atomic mass, and the formula for the hydride. That's the formula that has an X and an H in it. When you have done that, move on to the next slide. Two new cards are shown on the table. Find these in your deck. Place these next 2 cards into the table where they best fit into the pattern of the cards that are already on the table. So look at the 2 new cards and fit them into the table with the 5 cards that already exist. Remember, you're looking for patterns in the number trends and in the formulas. Do that now. Place your cards into your pattern and then move on to the next slide. Compare your solution to the one that's shown on the screen. Did you add those 2 new cards where they're shown? If yours is different, I want you to take a moment now to think about how yours versus this one. And I want you to understand why the cards fit best into the existing pattern where they are shown now. When you're sure you get that, here are 2 new cards. Put them where they best fit into the pattern of the cards that are already in the table. When you've done that, move on to the next slide. Don't move on to the next slide until you've placed your new cards. If you just move through and copy my solution into your solution, you're not going to be able to finish the rest of the assignment. It's important that you take the time now to try to figure out what patterns are in these cards. It is a bit like playing solitaire. Now I want you to look at this solution where the new 2 cards have been added. Find the card that has atomic mass 24.3. Can you tell why I decided to put it there rather than someplace else? As we go down, we see that ionization energy has gone from 899 to 738. And we see that atomic mass has increased from 9 to 24.3. Both cards have the same formula for chloride, and both cards have the same formula for hydride. That's the XH pair. And both have the same formula for the oxide. That's XO. Now I want you to look at the top part of the table and see if you understand why the second card was added to that part. Are you beginning to get the picture? Your task is to take the rest of the cards in your deck and complete the arrangement by placing the cards into the table where they best fit into the pattern of the cards that we've already laid out. There are better answers than others, but there's really no wrong way to do it. You will also notice that one of your element cards says missing element. That is exactly what Mendeleev contributed to the development of the periodic table that previous scientists had failed to recognize. When we place cards out on the table like this, putting them in logical order based upon a pattern, you will eventually find a place where you expect to have a card with a certain formula or a certain ionization energy or a certain atomic mass, and you won't find it in the deck. That is where your missing element will go. It will probably take you 15 minutes to finish this part. When you have finished arranging that, you will be putting the answer into your data sheet. So flip to the next slide now, where we have another assignment explanation for you that you can keep on the screen while you arrange your cards. Now that we've worked through this partway together, it's time for you to finish putting together the rest of your periodic table using the remaining cards that aren't in the pattern. Your final periodic table arrangement is to be written into the data sheet using permanent ink. Read the instructions carefully. It might take you up to 30 minutes altogether to complete this exercise. That includes the time you've already spent in this presentation. I want to point out to you that the very last post-lab question, you need to keep your periodic table together out on the desk, because in order to predict the properties of your missing element, you're going to need to use all of the data that's on the cards. When you're finished with that page, you're going to turn it in to Mr. Fain and Mrs. Schmidt.
Here is a likely arrangement of the element cards. You will now need your data sheet. In pen, copy the atomic mass of each element into your data table, beginning in the upper left corner. The next step is described at the top of your data sheet. You're going to be transcribing your group's periodic table arrangement onto this data table. So you will use a pen to copy the atomic mass of each element in its final location, beginning in the upper left-hand box. For each element, you will also use a blue pencil to copy its ionization energy. You will use a red pencil to copy its atomic radius, which is in angstroms. And you will use a green pencil to copy the element's electronegativity, which is in electronegativity units. We will not be writing the units in the data table itself. The first two have been completed as an example. So looking at the arrangement in the previous slide or on your desk, you'll see that it's mass 6.9, and the ionization energy is the top left-hand number, which is 520. It's in blue. Then we're using a red pencil for the element's atomic radius. That's 0.16. It's the top number on the right-hand side. And the last number in green is the element's electronegativity on the electronegativity scale. It's a 4-point scale. And that is the lower left-hand number on each element card, in this case 0.98. Moving to the right, the atomic mass of the next card in our pattern is 9.0. In blue, I've put the ionization energy. That's 899 kilojoules per mole. In red, we have the atomic radius in angstroms, 0.11. And in green, we have the electronegativity. On the 4-point scale, it's 1.57. So now you will continue, pause the video /podcast, and continue filling in your table across the way. You will also be predicting the properties of the missing element as described below and writing those numbers in the box provided. And when you've completed that entire assignment, you should use your phone to take a picture of your data table, and then you can assemble the cards and put them back together and return that kit to Mrs. Schmidt or Mr. Fain in class the next time you come. And as always, if you need any help, you can text me or you can contact me through Edmodo. Next, you're ready to estimate the properties of your missing element. Follow along in the data sheet while I read the instructions. This appears at the bottom of your worksheet. Predict properties of the missing element by averaging the properties of its nearest neighbors in any direction. Complete the card for the missing element by entering its predicted properties alongside the name of each property in the table below. Pause the podcast until you complete this, and then move on to the next slide.